In this online session, we're going to cover three topics. The first topic we're going to cover is how do you determine the overbooking limit. The second topic is how do you determine the weekly staff scheduling problem using Excel solver. The last topic we're going to cover is how to determine the protection level for airline seats. So first of all, let's talk about overbooking. So what is overbooking? So overbooking is accepting reservations for more than the available capacity. This is commonly used for airlines and hotels, even rental cars. Very popular practice in service industry. So for example, for airlines, if a particular airplane has 100 seats, how many reservations do airlines accept? Do they accept exactly 100 reservations? Oftentimes you will see that's not the case. Oftentimes they will accept more than 100 reservations. Why? Because some passengers with a reservation may end up not show up for the flight. So if you do not practice overbooking, the consequences you will have empty seats left, and that means you'll lose the opportunity to make more money. So that's why we overbook. We sell more seats than what we have. Similarly for hotels, rental cars, they do the same thing. So for hotels, if you have 200 rooms available, typically we'll take reservations for more than 200 reservations. So this is called overbooking. So we use overbooking to hedge against the significant number of no-shows. If everybody will show up, then we don't need overbook. So now the question is, how much to overbook? If we have 100 seats, do we overbook by 5 or do we overbook by 10? So obviously we need to look at the historical data, look at how many people will not show up. The problem here is what makes it difficult is oftentimes we don't know how many people will not show up. It's random. So sometimes you see everybody will show up. Sometimes you see 10 people may not show up. We don't know. It's very difficult to predict. So oftentimes, if you practice overbooking, there are two possible consequences. One, you overbook too much. Let's say if you have 100 seats, you overbook by 20 seats. That means you are taking 120 reservations. You overbook by too much. If you overbook by too much, then oftentimes you will end up not having enough seats available for every passenger. So think about what happened to the United Airlines, overbook by too much. The second situation is that you don't overbook enough, overbook too little. If you overbook too little, what happens oftentimes you will end up having empty capacity, empty seats available. So it means you lose potential revenue. So these are the two possible consequences. So a good overbooking strategy should balance the two. Okay, you don't want to overbook too much. You don't want to overbook too little. So we should choose overbooking strategy, try to minimize expected opportunity cost if idle capacity, as well as expected cost of turning away reservations. So in this topic, we're going to learn a mathematical model. How do we determine the optimal overbooking limit? So again, I want to highlight the term, so overbooking limit. So what is overbooking limit? So overbooking limit is the number of reservations booked beyond the available capacity. For example, if you have 100 seats available, you take 105 reservations. So the overbooking limit is 5. It's now 105, it's 5. So it's the extra number of seats, extra number of reservations you take. This is called overbooking limit. So if I have 200 rooms available, I take 210 reservations. That implies that my overbooking limit is 10. Okay, the extra amount is called overbooking limit. So to determine the overbooking limit, it depends on the number of no-shows. That means we have to look at historical data. We have to record the historical data, see typically how many people will not show up, and use the data to determine the overbooking limit. So in this topic, we're going to cover two different methods to determine the overbooking limit. One is called a cost analysis. So we use a table, we fill the table to determine the overbooking limit. A second one is called critical fractal criteria. It's a little easier. The second method is a little easier. You should know both methods to determine the overbooking limit. So let's look at an example. This is a hotel example. So for this particular hotel, people may not always show up. If somebody have a reservation, they may not end up showing up. So this is a historic data. So sometimes the number no-show is 0. When the number of no-show is 0, that means everybody show up. Okay, everybody with the reservation shows up. Sometimes you can have one no-show, one passenger or one guest end up not showing up. Sometimes you could have 2 all the way to 9. The maximum is 9. So this is historical data. So I have different situations. How likely is each situation going to occur? So this is a corresponding probability. So with probability 0.07, in other words, with 7% probability, everybody show up. There's 0 no-show. With probability 0.919, or in other words, 19% time, that's 1 no-show, and 22% time, 2 no-show, 16% time, 3 no-shows. So these are the corresponding probability. These are the number of no-shows. This table comes from historical data. So you need to record the data in order to determine the optimal overbooking limit. So let's see, what is the average? So this is the all possible number of no-shows. This is the corresponding probability. Now the question is, what is the average number of people who will not show up? So we can calculate expected value. So we 0 times corresponding probability 0.07 plus 1 times corresponding probability 0.19 plus 2 times corresponding probability 0.22 plus 3 times corresponding probability 0.16 plus 4 times corresponding probability 0.12. You do the math, you get 3.04. So average-wise, roughly speaking, 3 people will not show up average-wise. But sometimes can be 0, sometimes can be 9, but average-wise about 3 people. So some people may ask, then does that mean we should overbook by 3? Because average-wise, there are 3 people who will not show up. Does that mean we should overbook by 3? The answer is not. It's too simple. When you determine the overbooking limit, the historical data about the number of no-shows is important. A second piece of information we should look at is how important. As we discussed in the beginning, there are 2 possible consequences. You can either end up overbooking too much or end up overbooking too little. The consequence might be different. So for example, look at the hotel case. If you overbook too little, then the consequence is a lot of times you will end up having a lot of empty rooms. So these empty rooms have a cost. It's called opportunity cost. So for example, for this particular case, the opportunity cost for each empty room is $40. So if you have 1 empty room, that represents opportunity cost of $40. Because otherwise, I could have sold the room for $40 per night. So this empty room, I have a cost, which is $40. It's called opportunity cost. On the other hand, if you overbook by too much, everybody show up, then you don't have enough rooms available for all the customers. Then what typically hotels, airlines will do, they have to figure out a way to accommodate the customers. For hotels, typically they will walk the customer to a nearby hotel, typically a better hotel, and pay the price difference and also pay some compensation because it causes inconvenience for the customer. So when this happens, when you overbook by too much, there's an overbooking cost. In this case, it's $100 for each guest walked. You have to walk each guest to a nearby hotel. It costs you about $100. That represents, for example, inconvenience plus the price difference between your hotel and nearby hotel. So you can see the opportunity cost and the overbooking cost is different. So in this case, the opportunity cost is only $40, but overbooking cost of $100 is much higher. So you can imagine in this case, overbooking and underbooking, in other words, booking too much or booking too little, the consequence is very different. If you overbook by too much, the consequence is more serious. So we should take that into consideration when we determine that overbooking limit. So now let's look at the procedure. How do we do that? We call it cost analysis. First of all, we have to fill a table. Look at this table. The first column shows the number of no-shows from 0 all the way to 9. The second column shows the corresponding probability. The first column, second column are typically from the problem, from historical data. So it's just copy-paste. In this particular example, it's copy-paste. Now we have to fill the rest of the table. So on top, the top line shows all possible overbooking limit. I want to try different overbooking limit to see which one is the best. So I can overbook by 0, or 1, or 2, or 3, all the way to 9. And so I list all the possible overbooking limit. So this is the same as the number of no-shows. The number of no-shows goes from 0 to 9. That means possible overbooking limit goes from 0 to 9 as well. Now let's look at the first one. What will happen if we overbook by 0? What does that mean? If I overbook by 0, that means I do not practice overbooking. I sell exactly the same number of seats I have. Okay, so that's called overbooking limit 0. I do not practice overbooking. So in this case, if I do not practice overbooking, if the number no-show 0, the number no-show 0 means everybody show up. I don't overbook, everybody show up. What will happen? Is there a cost? The answer is no, there's no cost. It's perfect. I have 100 rooms. I don't overbook. I take 100 reservations, and everybody shows up. No-show. Everybody show up. I take a 100 reservation. Everybody show up. This represents the perfect situation. So there's no cost. So what will happen here? If I overbook by 0, that means I take 100 reservations, and there's one no-show. There's one no-show. So one people end up not showing up. So one people not showing up. So what's the consequence? The consequence is I will have one empty room. That represents what cost? Represents opportunity cost. I have one empty room that represents opportunity cost. How much? $40. Similarly, if I overbook by 0 and 2 people do not show up, so 2 customers do not show up, what will happen? If 2 customers not show up, that means I will have 2 empty rooms. So when I have empty rooms, that represents opportunity cost. How much? Double, right? My cost will double because I have 2 empty rooms. So opportunity cost will be $80 for 2 rooms. So what if I have 3 no-shows? If I have 3 no-shows, again, I will have opportunity cost. Total cost will be $120 because I have 3 empty rooms. So for 4 no-shows, the cost of $160, $5, $200, and you can fill the rest of the column. So these numbers represent the cost if I overbook by 0 under different situations. So I fill the first column. Now, let's see what will happen if I overbook by 1. Okay, overbook by 1. So what does that mean? If I overbook by 1, assume we have 100 rooms again. Assume we have 100 rooms available. I overbook by 1. That means I sell, or in other words, I take 101 reservations. I sell 1 extra room. So I take 101 reservations. In this case, let's look at each of these possible scenarios. So if there's 0 no-show, I take 1 extra reservation and everybody show up. No no-show, everybody show up. That means how many people will show up? 101 people will show up. So I take 101 reservation, everybody show up. In other words, 101 people show up. How many rooms I have? 100 rooms available. that means I do not have enough rooms available for everybody. So I have to walk how many customers? I have to walk one customer to a nearby hotel, pay the cost, which is called the overbooking cost. So how much? I have to walk one customer, so it's going to be $100. So what if I overbook by one and one people not show up? This is a perfect situation. So I overbook by one, that means I take 101 reservations. And one people not show up, that means eventually I only have 100 customers show up because one people with a reservation will end up not showing up. So this is a perfect situation. It's perfect. I have exactly 100 room for 100 customers. So that means my cost is 0. So what if I overbook by one, two people not show up? If the number no show exceeds the number of overbooking limit, I overbook by one, two people not show up, the consequence is I will end up having one empty room. I have one empty room, that cost will be $40. What if I overbook by one, three people not show up? So three people not show up, the 3 exceeds 1, the number no shows exceeds the number of overbooking limit by how much? By 2. That means what? I will end up having 2 empty rooms. So 2 empty rooms, that means $80 opportunity cost. So if I overbook by 1, 4 people do not show up, I will have 3 empty rooms, which represent the cost, opportunity cost of $120. So similarly, you can fill the rest of the column. So let's do one more column. What if I overbook by 2? I take 102 reservations and everybody show up. 0 no show, that means everybody show up. So everybody show up, I take 102 reservations. Everybody show up, which means I have to walk 2 customers to a nearby hotel. So which represents overbooking cost of $200 because 2 customers. If I overbook by 2, 1 customer does not show up, that means I will have to walk only 1 customer to the nearby hotel. So my cost will be, overbooking cost is $100. If I overbook by 2 and exactly 2 people not show up, so overbook by 2, 2 people not show up, this is a perfect situation. That means I have a perfect situation, so there's no cost. If I overbook by 2, 3 people not show up, I will end up having 1 empty room, so which represents opportunity cost of $40. If I overbook by 2 and 4 people not show up, I will end up having 2 empty rooms, which represents an opportunity cost of $80. And you can fill the rest of the column. So you can do this for each of these possible overbooking limits. You can do this for 3, 4, 5, 6, 7, 8, 9. So I will skip the rest of it. You can try on your own. So just fill the cost table. Okay, fill the cost table. So if you know how to do one column, you know how to do the rest of it. It's similar. It's a little bit tedious. So next step is I look at all these possible overbooking limits from 0 to 9. Should we overbook by 0, or should we 1 or 2, or maybe 9? So what is the optimal overbooking limit? So the optimal overbooking limit depends on the cost. Look at these cost numbers. So for each possible overbooking limit, I have 9 different costs. It's just too much to compare. So what I want to do for each column, or in other words, for each possible overbooking limit, I want to calculate what is the expected cost. In other words, what is average cost? So for example, let's look at overbooking limit 0. If I overbook by 0, what is the average cost? So what I can do, I take expected value. So it will be 0 times corresponding probability, which is 0.07, plus 40 times the corresponding probability, which is 0.19, plus 80 times corresponding probability, which is 0.22, plus 120 times the corresponding probability, which is 0.16, plus 160 times the corresponding probability, which is at 0.12. So do the math. Expected cost. I have the number here. So you do the cost, you get 121.60. So that is expected cost. So this is expected cost. Similarly, you need to do the expected cost to calculate expected cost for overbooking limit 1. So how to do it will be 100 times the corresponding probability, which is 0.07, plus 0 times the corresponding probability, which is 0.19, plus 40 times corresponding probability, which is 0.22, plus 80 times corresponding probability, which is 0.16, all the way to the bottom. So you get 91.40. You can do this for overbooking limit 2, which is 87.80, for overbooking limit 3, which is 115, and the rest of it. So now, for each possible overbooking limit, I calculated what is that expected cost. So now the last question is, so what should be the overbooking? What should be the optimal overbooking limit? Shall we overbook by 0 or 1 or 2 or 3 or maybe 9? So how do we choose the optimal overbooking limit? We look at all these expected costs. We look at which is the lowest cost. So which one is the lowest cost? You can see 121, 91, 87, 115. So starting from here, it's decreasing, and then it's increasing again. So you can see the lowest expected cost is 87.80. So 87.80 corresponding to an optimal overbooking limit of 2. So that means the optimal overbooking limit is 2. We should overbook by 2 rooms. So this is the lowest cost. This is the optimal overbooking limit. So for this particular hotel, the optimal overbooking limit is 2. So if we have 100 rooms available for the hotel, how many reservations shall we take? We should accept 102 reservations because the optimal overbooking limit is 2. So this concludes the example. That's how we do it. Okay, by performing a cost table analysis, we look at the lowest total cost and we determine which is the optimal overbooking limit. So that is method 1, cost analysis. There's another way to do it. It's called critical fractal criteria. It's a little easier, a little. So there are 3 different steps. Step 1 is identify opportunity cost and overbooking cost. So for this particular example, it's pretty simple because it's already given. So opportunity cost, we use that notation CU. U also represents underbooking. Okay. So CU for this particular example is $40. If you underbook, that means in other words, you do not book enough, you will have empty rooms. So for empty rooms, the cost is $40. The second cost we need to identify is the overbooking cost. We use a notation CO. O stands for overbooking. Okay, overbooking. So for this particular example, the overbooking cost is $100. So that is step 1. So simple. So identify 2 costs. Step 2 is also very simple. Calculate something called critical fractal. So what's the definition for critical fractal? It's that CU divided by CU plus CO. So this is that definition for critical fractal. You don't have to memorize the formula. The formula will be provided in the exam. So for step 2, just use the formula to calculate the critical fractal. So CU from step 1, which is 40, CU is 40, CO is 100. So we plug in the right number, we do the math to get 0.286. So that's step 2. So 1 and 2 are pretty simple. Step 3 is might be a little bit confusing for some people, but once you see the example, it should be clear. So step 3, identify the largest overbooking limit, X. We use X to represent overbooking limit, such that the probability D is less than X. What is D? D is a no-show. So D is no-show, X is overbooking limit. So such that the probability that no-show is less than overbooking limit is no more than the critical fractal calculated in step 2. So when you read it, it's probably not very straightforward. Let's look at the same example. So this is a hotel example, same example. Same example, we have the first column, second column, it's copy-paste. So number no-shows, we use D to denote the number no-shows from 0 all the way to 9. And second column is simply the corresponding probability. Okay. So this is number no-show. This is the corresponding probability. It's copy-paste. So how to do it? So we try to determine the optimal overbooking limits. Again, we're going to start with the lowest possible overbooking limit. The lowest possible overbooking limit is 0. So X can be 0. We'll try the first one, 0. Okay. We'll try the lowest possible overbooking limit, 0. So if you overbook by 0, under what conditions? We want to identify the condition. D is less than X. D is strictly less than X. When D is strictly less than X, that means no-show is strictly less than X. Look at all these numbers. When does that happen? Okay, when does that happen? The overbooking limit, X is 0. Under what conditions? D, no-show, will be less than X. You can see if X is 0, there's no way D will be less than X, because look at D. D is from 0 to 9. It will, any numbers from 0 to 9, it will never be less than 0. It never happen. It will never happen. So if overbooking limit is 0, D will never be less than 0. So the probability is what? It's never going to happen. So it's 0. It will never happen. So then we can try the next overbooking limit. The next highest overbooking limit will be 1. We can try 1. So what if we overbook by 1? Let's see. If we overbook by 1, under what conditions D will be strictly less than X? So look at all these numbers. Which number? 0, 1, 2, 3, 4, all the way to 9. Which number? These are all D's. So which number is strictly less than 1? So which number? 0. Only 0, right? 0 is less than 1. So we can highlight this. Okay, so only under this condition. Only if D is 0, D is less than X. X is 1. So what is the corresponding probability? The corresponding probability is 0.07. The 0.07. Okay, 0.07. So then we compare this number to the critical fractal, which is 0.286. So does 0.07 exceed 0.286? 0.07, does 0.07 exceed 0.286? The answer is that no. If the answer is no, we continue. Okay? If the answer is yes, we stop. So we continue in this case because 0.07 is less than 0.286. In other words, 0.07 does not exceed 0.286. We continue. So what's the next overbooking limit? The next overbooking limit is 2. So let's see what will happen if we overbook by 2. If we overbook by 2, under what conditions? D will be less than X. So X is 2, so D will be less than X. That means D can be either be 0 or 1. These are only 2 possibilities. When D is at 0 or 1, D is less than X. X is 2. So we highlight these 2. So only when D is 0 or 1, D is less than X. X is 2. So what is the cumulative probability for these 2 different situations? So what is total probability for these 2 situations? The total probability is 0.07 plus 0.19, which is 0.26. Yeah, 0.26. So now we ask a question: does 0.26 exceed the critical fractal calculated in step 2, which is 0.286? The answer is not. If the answer is no, we continue. We try the next overbooking limit. So next overbooking limit is 3. So next overbooking limit is 3. So x is equal to 3. We want to see when is d less than x. When x is 3, when is d less than x? So d can be 0 or 1 or 2. So there are 3 different situations when d is less than x, x is 3. So these are 3 different situations when d is 0 or 1 or 2. So in the right side, so the cumulative probability, we add these 3 numbers because there are 3 different situations. So we add these 3 numbers, so which is 0.07 plus 0.19 plus 0.22. We got 0.48. Then we check, does 0.48 exceed the critical fractal? The answer is yes, because 0.48 is larger than 0.286. So we stop. Okay, we stop. We stop here. The optimal overbooking limit should be 2. Yes, should be 2. We'll go back, but we'll go back because look at step 3. Step 3 says identify the largest overbooking limit x such that the probability is no more than. Okay, this already exceeds. Is no more than. The largest one, no more than. This one already exceeds. Okay, this one is not the optimal overbooking limit. So whenever we identify a probability that exceeds the critical fractal, we always go back to the previous step. We go back to the previous step. This is the optimal overbooking limit. Okay. So in this case, the optimal overbooking limit is 2, as 2 is the largest overbooking limit, such that the probability is no more than the critical fractal. Because 3, if you overbook at 3, the probability already exceeds. We don't want to exceed, and no more than. So we should go back, always go back to the previous step.